Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Welcome to the Automotive Diagnostic Podcast. Thank you for tuning in. Today I'm going to tell you about a case study I recently went through with a Chrysler 300. It's going to talk about ASD relay, which isn't anything groundbreaking. The diagnosis, nothing groundbreaking. Really, the reason I'm bringing it up, the reason I'm discussing it, is to touch on another topic related to diagnostics, something that we run into a lot of the time, something I've definitely experienced myself, and case in point is what I'm going to tell you today, is tunnel vision during diagnostics. How we can put the blinders on, if you want to say it that way. There's another phrase that I'm sure you've heard before: you can't see the forest for the trees. And the actual definition of that statement is, it is an expression used of someone who is too involved in the details of a problem to look at the situation as a whole. And boy, oh boy, do we experience that a lot as automotive technicians in diagnosing problems. We can get that tunnel vision. We can get zeroed in on one thing and forget to look at the system or the component or the whole car, for that matter, just as a whole. Bring it back to the basics. I say that a lot, as the basics are so important, and that holds true for just about anything on the car. So as I walk you through this today, you'll see why I'm relating the topic of tunnel vision to this particular diagnostic. So we'll start off. This is a 2005 Chrysler 300, has the 3.5 liter V6. I was called in to diagnose this to a shop. They've had this vehicle at their location for about 3 weeks. It's actually from a used car lot that brought the vehicle in there, and the car lot owner had done some repairs himself, or attempted some repairs himself, in order to fix this vehicle. Unsuccessful. They brought it to the shop. They've tried a few things, also unsuccessful. So they call me up, and the way it's presented to me is, hey, we've got this Chrysler, and the issue is that it keeps setting codes for the electronic throttle system. Okay, so this has an electric throttle on it. There's no cable between the pedal and the actual throttle plate. Nothing new here. Again, this is a 2005, so 15-year-old technology. This has been around for a while. But anyways, I come in, and again, that's how it was presented to me. Hey, let's figure out what's going on with this throttle. They also tell me the previous repairs that have been done to this particular vehicle. So we are on our third PCM. Of course, the last two that are in there, and the one that is present on the vehicle right now, are remanufactured PCMs. This era of Chryslers, it is a little bit more difficult to get brand new PCMs. Even the ones you get from the dealer can be remanufactured. But, of course, anything remanufactured, and especially PCMs, you're a little suspect. But they're not willing to keep throwing PCMs at it, because with each one, it's the same problem. They're also on their second throttle body motor, the entire assembly, not just the motor. They've replaced the entire throttle assembly. Now, this again is aftermarket, so it's not factory. So I do need to take that into account, that, okay, maybe this third PCM has an issue. Maybe this aftermarket throttle body has an issue. There's no such thing as a new part. I've been burnt by that plenty of times. So I'm going to go into it fresh. I'm just going to look at this and treat it as this thing hasn't been worked on before. It hasn't had parts replaced. But I'll keep in the back of my mind that we've got some potential, reman parts that aren't up to standards of what needs to be on the vehicle. So do my full system scan. I'm really focused in on the PCM here, because that's what they're after, is the throttle codes. And just like they said, there are two throttle codes, electric throttle codes, in the PCM, powertrain control module. And these are hard faults. So you clear these faults and they are immediately back. Of course, I love hard faults. I love stuff that is constantly there. It is right now. It is happening. I can duplicate it every single time I turn the key on. This is great. This should be a slam dunk. It should be easy. So I'm going to jump in. First thing I always want to do is understand the codes, understand what exactly they mean. And one of the codes is P2100, electric throttle motor circuit. So specifically it's saying the circuit is either open or shorted. And the second code is a P2111, which is ETC, or electric throttle control, unable to close. And the way these systems work is when you key up the vehicle, when you just turn the key to the on position, the motor goes through a self-test, or at least it should. The PCM is going to close and then possibly open it fully, or at least open it to a percentage. It's going to send the commands to the motor, and then it's going to watch the throttle position sensors built into the throttle body to verify that the motor actually moved to the position that the PCM desired. And this is to assure the PCM that once the vehicle is running, it is going to have proper control over the position of the throttle blade, because that's an important thing to have, especially in electronic situation where you don't have a physical cable. The PCM needs to make sure that this thing's going to work properly. We're not going to mistakenly wedge the throttle wide open and crash the car. Obviously can't have that. So that's where those self-checks come into. So as soon as I key this thing up, the PCM goes through its self-checks, or at least attempts to, for this throttle motor. And I can hear, or well, I should say there's a lack of hearing in this case, that there's nothing happening. You can normally hear this throttle motor move. And I physically looked at it. I took the air duct off, shined a flashlight on it, keyed it up several times, and there's nothing from this motor. It's not moving, okay? So at least one of the codes, unable to close, is legitimate code from the PCM. And I verified that by hooking up the scanner, looking at the throttle position sensors. There's two of them. They use a redundant sensor in this case, again, for safety concerns in an electric throttle. And then they have the two wires for the motor that actually move the throttle. But I keyed it up and I moved the throttle with my hand, and I could watch both throttle position sensors respond. I even did a relearn on the throttle position just in case it was out of whack, and that didn't make any change. No matter what happens when I key this thing up, the throttle position doesn't move, doesn't even attempt to do anything. So the first thing I did was I want to verify the circuitry from the PCM to the throttle motor itself, because again, throttle body has been replaced, PCM's been replaced. Let's take a look at the wiring here and see. So the first thing I did was I actually just disconnected the PCM and I disconnected the throttle motor, and I sent power, full battery voltage, through one wire, connected a 9000 series headlight bulb on the other end, and then I connected the other side of that headlight bulb to the second wire. Again, this is for the 2-wire electric motor portion of the throttle. And then on the other side, on the PCM connector, I grounded that wire. Okay, so basically I'm just using the wires on the car to jump power and ground to a headlight bulb. And that goes all the way from the PCM through the harness up to where the throttle body is. So I'm testing the entire circuit, well, both circuits, for integrity. Can they carry current? And 9000 series headlight bulb is going to pull about 5 amps. Electric throttle motor, somewhere in the same neighborhood, but I like using a headlight bulb because it really loads the circuit. Ohm checking, which the tech mentioned that he did ohm check the wires, is great, but you can have a circuit that will test correctly on an ohm meter, pass an ohm meter test, but you could have one strand of wire pass an ohm meter test. Is that going to be able to handle 5 amps to move a throttle or any type of output that requires some current? Not necessarily. So if we load the circuit using a headlight bulb, we're effectively, we're testing those wires in the way that they are normally used to carry current. Well, in this case, it works great. And the light bulb lights up. And with this test, I know that those wires are not shorted together at any point. They're not shorted to power or ground at any point. They are able to carry current from one point, to the load in the circuit, and then back to the source effectively. So I'm no longer worried about the circuits. I did check pin fit at this point, but I didn't see any issues on either the PCM or the throttle body side. So my next question is, okay, can this throttle body actually move? What's happening there? So I plugged in the throttle body, but I left the PCM connector disconnected. And now what I did is I sent power and ground in through those two wires, just like I did with the headlight bulb, but with the throttle motor plugged in. So how this circuit actually works, again, it's just a 2-wire DC motor that's going to move the throttle plate in this case. And it's very simple. It's just power and ground. But the PCM is going to alternate power and ground on the two wires. So at one given point when it wants the throttle to open, let's say, we'll have power on one wire and we'll have ground on the other wire. And then when it wants to close the throttle, it's going to flip-flop. So the one that had power now has ground, and the one that had ground is now power. It's called an H-bridge circuit within the PCM, and it has the ability, there's 4 transistors, and it has the ability to send either power or ground on each of those wires. Now, they won't be powered up at the same time or grounded at the same time. It's always going to be alternate, so that it can move that motor in one direction. And it can also hold the motor in a position by quickly flip-flopping back and forth. So, this kind of circuit needs a controller. It needs a computer module with drivers in order to operate it. There's no way a normal switch or relay or anything like that would be able to operate an electric throttle. The power and ground have to come from the computer module involved, which is the PCM in this case. So back to my test. I send power and ground on these wires to the electric throttle while it's plugged in. Motor flops all the way open. I release it. I flip my wires. Motor closes all the way, 100% closed, because in its default position, it's about 9% open. And that's so that if it goes out, if it dies, you can still idle the vehicle. The throttle's not completely closed. You're not dead in the water. You could at least idle it to the side of the road, to get it safely somewhere before you call for a tow truck or fix the vehicle. So that's where I'm at right now. Is I'm pretty confident the throttle motor is going to work. Or it does work. I can see it's working, and the circuitry is working. So at this point, I'm like, okay, what is the PCM doing or not doing? So I plug everything back in the way it's supposed to be, and I pull out the scope. And I want to see on these wires, the control wires going to this 2-wire motor, what is the PCM doing, if anything, when I key this thing up, when I put it into its self-test mode. And again, it's setting the code every time I do this, of course. So I have my scope set up, and I look at the voltage that is on each of these wires while I'm keying it up. And as I key it up, every single time I see some activity. I see the PCM attempting to do something. So it's active. At least it's trying to move this motor. And again, keep in mind, the motor is not giving me a hint of movement. I even put a current clamp around one of the wires going to the throttle motor. I was getting just about a 0.5 amp of current at this point during this activity, but no actual movement. So now I'm seeing that the PCM's attempting to do something, but it cannot actually move this throttle body. So as I look at the details on my scope, what I'm seeing is that there are 5-volt pulses going to this motor when it's trying to move it. And if you've ever looked at one of these circuits where a PCM or control module is trying to move an electric throttle body, you should actually see a 12-volt pulse. One of those wires is going to be pulsed to 12 or system voltage. The other wire is going to be pulsed to a ground. That way you're applying power and ground to a motor in order to spin it. But again, in this case, I'm only getting 5 volts on the power side of this wire. Now, if I look at the flip side, on the ground side of it, it is able to apply a full ground to the motor on the side that it's trying to move, but not on the power side. So now my focus is on the PCM. Why is the PCM not able to apply full voltage to this electric throttle motor when it needs to? Why is it only 5 volts? So again, this is a remanufactured PCM, so always the potential the drivers inside are failed, but they said that this is their 3rd one with the exact same problem, so I'm not going to call a PCM just yet, and nor should you. You obviously have to do some tests before you call a control module for any reason. My next obvious check is to check powers and grounds for the PCM. Let's see if this thing has the powers and the grounds in order to supply power to this motor. Because again, in a lot of cases when we're talking about outputs, the outputs are going to have a supplied power from another source or a supplied ground from another source outside of the module, like let's say a fuse or a relay. And then the control module is going to operate that output on the opposite side. It's not the case with the throttle motor because of the reason that I explained with the H-bridge circuit. It's just too fast, it's too complex, and the computer needs to be in control of both sides of the motor. So what I'm getting at here is the electric throttle motor needs to have power and ground supplied directly from the PCM, but the PCM needs to get that power from somewhere else. Can't just generate it out of nowhere. So again, powers and grounds at the PCM. Check all my grounds first. I believe there was 2 of them on this particular PCM. And once again, I'm going to load these with a headlight circuit. And I'm also going to check the voltage drop to the PCM while I'm loading those circuits. Now I disconnect the connectors from the PCM and I'm checking right at the pins. All the grounds check out good. They brightly light the headlight bulb that I'm using to load the circuit, and the voltage drop is within tolerance, 100 millivolts, 200 millivolts, somewhere in there. I'm happy with that. So then I check my ignition feeds. These are the feeds to wake up the PCM, to turn it on. With the key on, I have ignition feeds on my 2 wires that I need them on the PCM. I check my constant B+. Same thing, good. This is all good with my headlight pulling 5 amps through these wires. That's going to be enough to operate this PCM. But there's one more piece on these Chryslers that you do have to check. And if you're familiar with Chryslers, you know all about this, and I don't have to explain it to you. But in case there's anyone who doesn't work on Chryslers, is not familiar with them, they used what was called an ASD relay for many, many years, automatic shutdown relay. The purpose of this relay is when you key up the vehicle, the PCM's actually going to turn on this ASD relay for a short period of time. And this ASD relay powers up a lot of stuff. It powers up all the coils, all the fuel injectors, and this is the important part for me, it actually sends a power source to the PCM. So again, think of that. The PCM turns on the relay when it gets an ignition wake up, but then the relay sends power to the PCM that the PCM uses to operate components, just like the electric throttle body, which you'll come to find out is the case here. So the idea of this relay, again, is if the PCM does not see a crankshaft sensor signal, okay, it doesn't see the engine rotating within a few seconds of key up, it's going to turn off that relay. But as long as the PCM sees a 5-volt square wave from that crankshaft sensor, okay, the engine's rotating, it is going to activate that ASD relay and keep it activated. So if you're going to check an ASD relay, and you're just keying it up, you're going to want to have a helper so that you can see, because that thing's only going to be on for a few seconds. So in a normal key on position, and you go to test those powers at the PCM, you're not going to have anything except for those first few seconds when you turn the key on. So I had the tech there help me turn the key on a couple times, and I watched for power. There was actually 2 wires that the ASD sends power to the PCM on. And I checked for power on those, again, with my headlamp bulb. I'm loading it, and I get nothing every single time it keys on. So I'm like, okay, let's just eliminate the relay here. Oh, and the other thing, this is important to mention, I could hear the relay clicking. I could put my hand on the ASD relay and it goes click, click, click. But for those of us that have been doing this for a while, that doesn't always mean that the relay is working, and it didn't in this case. So I pull the relay out, I put a jumper wire across the 2 terminals, 30 and 87, so that I'm just sending direct power. I'm doing the job of the relay, and now I don't even have to worry about cycling the key. I'll just leave the key on. Now I'm getting power to my PCM on those 2 circuits. And I go back to my electric throttle, I start doing my key cycles, and it self-tests, it moves, and guess what? It stops setting the codes that I had. All right, so I pull the relay apart, it's got some burnt contacts in it. It was clicking, but it wasn't able to actually handle the current that's going through that relay, because there's quite a bit of current. Simple, easy fix. Took me way too long to find this, though. And here's the reason. Here's going back to a little bit of tunnel vision. When I came in, I was dead focused on these codes that they were telling me. And when I scanned it, it had those codes in there. I got that up on my scan tool. I'm like, okay, it's hard fault. I'm going for this. Here's what I never did. And this is a huge mistake on my part. I never tried to start this car. I wasted quite a bit of time tracking down the electric throttle circuit and how this is all working, when if I would have tried to start this thing, it would not have started, because the ASD relay powers the coils, it powers the injectors. Okay. And I would have taken a completely different approach had I had this in my brain that this is a no start. I think the shop assumed that I knew that it was no start, and I assumed they would tell me or lay it out specifically, like, this car doesn't start. But it was presented to me as these are the codes, and they plugged in their scanner because of the no start. They saw those codes and they said, this is what I need to go after to fix this problem. I was not taking that approach. I wasn't trying to fix a no start. I was just trying to fix these codes. And I found the reason why, but in a roundabout way, because going back to the statement, I couldn't see the forest for the trees. I was focused in on one problem, and I didn't look at the car as a whole. As a whole, I always say, make sure to test drive cars. Make sure to test drive cars. Well, dummy, part of test driving cars is actually starting the engine. So, boy, would that have saved me an hour of screwing around and pulling out my scope and everything, and I would have solved the problem a lot sooner for just a silly relay. But I thought this case study was pretty interesting because of that reason, because of how we can waste time when we're zeroed in with our blinders on and we don't step back and take a look at the whole picture of what's going on. I didn't ask the right questions here. I wasn't detailed enough in my my pre-interview of the customer. In this case is a shop. But all this messing around just for an ASD relay. So hopefully you gain something from that. Hopefully maybe you didn't know how an ASD system works on a Chrysler. Maybe you didn't know how an electric throttle body system works. I hope you gained something from that. But other than that, just take those blinders off, look at the whole picture. And that is all I've got for you today. Thank you again for tuning in, and hopefully we'll see you again.